All right, well, welcome everybody. It's 12 o'clock. And, I'm Charles Gainier. Welcome to the meeting for Eagle Rotary Coastal for September the 6th. We're happy to have you here today. We'll begin our meeting as we always do with a pledge, the four-way test, and an opening prayer. So bear with me while I get all that. Please join me as we recite our Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. I'll also ask Philip Zimmerman to lead us in an invocation, please.
Sure. Heavenly Father, thank you for sparing us the Gulf Coast region of a stronger than possible storm that came through, tropical storm. And, it came in as a low category 1 hurricane into the Biloxi area. I know that some of our members experienced down in the Florida Keys may have experienced some wind, and others along the Gulf Coast. We just thank you that you protected us, and to those who didn't have property damage, and any other situations that came out of that. And again, we just thank you for it not being worse than it could have been. For all this we made.
Thank you, Philip. And we'll now recite the things that we think, say, and do our four-way test. Is it the truth? Is it fair to all concerned? Will it build goodwill and better friendships? Will it be beneficial to all concerned? Just a quick bit of club business. We are actually deeply involved in facilitating District 6200 e-training. Basically, using the Zoom format that we use, we facilitate that on behalf of District 6200. The next one is scheduled for this Monday coming, September the 10th. You should be receiving email invitations from Frank Bradshaw inviting the link. The Zoom meeting is ours. But anyway, it has been a really engaging meeting. It's at 6:30 on Monday, and you're welcome to join us. But again, it's an opportunity for us to highlight our club. There's also been quite a bit of activity going on. Our Rotarians are extremely active, and I just wanted to give a little time for a couple of members to kind of bring us up to date on some things. First of all, I'd like Val to give us just a synopsis of the symposium. And then Stan, I believe you got an event coming up later in the year that we need to hear about. So Val, just a quick synopsis, if you don't mind, of what happened last week.
I'll make this very quick. 7 years ago, we sponsored a series of resiliency forums across the Gulf Coast with America's Wetland Foundation. And we returned to Terrebonne Parish and Lafourche Parish for a second series, which we're calling Adaptation Forums. Resiliency being how you recoil or bounce back after some negative events, and adaptation is what actions you take to remain solid and secure. And we had a good lineup of speakers. We'll come out with a report in a week that we'll issue with what was new that was discussed and thoughts on adaptation for the region. That will be followed on November 7th by a statewide summit, which will be a second summit based on the Louisiana Coastal Master Plan. And at that time, we'll also launch the Louisiana Coastal Exchange, which is a compendium of private sector projects, past, current, and proposed for coastal restoration. I can go further, but in the interest of time and our speaker, I will stop there.
Thank you, Val. And Val, one other quick update too. So the tree planting that Rotary will participate in, just for everybody's benefit, so the scheduled date for that is probably first quarter of 2019. Is that correct?
Yes, if not late December. There is some thought. It depends on the weather, and they're, I think, looking possibly now at December. So as soon as we know, we will send out a notice for volunteer activity on the planting.
Very good. Because again, our club has a pivotal role locally, to draw the community into deeper involvement in that. Thanks, Val.
Very pleased.
Stan, I appreciate it. Stan, you had some news for us. I know it's an event coming up in December, but I think it'd be good to hear about that if you don't mind.
Sure. Can you hear me?
Yes, sir.
On December the 11th through the 13th, we are hosting a global resilience summit that will be at the Breakers, Palm Beach, which is one of the top 10 hotels in the world. And we'll have people from all over the world that will be in attendance there. And it is primarily focused on coastal resilience. So it is only 40 hours long. So it's the evening of the 11th, all day on the 12th, and the morning of the 13th. And some keynote speakers that we've got that totally not confirmed yet, but pretty close. One of them is Brock Long, the new administrator for FEMA, and also the ambassador from the Netherlands to the United States. So a lot of interesting folks from all over the world are going to be there. So December 11 through 13.
I believe also our own Garrett Cicchini will be there as well as a speaker. So again, one more presence of our club membership, making a big difference in the world. And again, not to take too much time, but I thought the motivation for the host hotel was very interesting. Stan, just real quickly, why is the host hotel involved?
Well, the Breakers has experienced 2 out of the last 5 years of salt water in their restaurant that faces the Atlantic, and it's not during hurricanes. It's just during king tides. And so they get it. The Breakers board of directors are all Wall Street guys, and so they become a sponsor as well as the venue.
Interesting. So again, it just what a tell of the tape. How what we're doing is so highly relevant, not only in our own coastal communities, but it seems to be ever expanding. And we're looking forward to being there. It sounds like a great venue, and I hope everybody will make it.
And Charles,
to attend if possible.
Charles,
yes.
If I may, Stan, this is Val Marmillion with America's Wetland Foundation. We're happy to share with you, and we can do it online, the results of our McKinsey and Swiss Re study by zip codes of the impact of sea level rise and climate change on built infrastructure in the Gulf Coast, if that's something that could be useful to you.
Yeah, that'd be great, Val.
Love it, love it. That's what we're to do. Well, very good. Well, thank you for that pause, and thank you, Stan. Thank you, Val. Let me turn it over to Tyler Ortico, who is our Rotarian of the day, who will introduce our speaker.
All right, thanks a lot, Charles. Very happy to introduce a friend of just about 18 years now. So most recently, Steve is moved to NCSU in Raleigh, where he's the director of the Marine Aquaculture Research Center. Prior to that, he was a professor at LSU in biological and agricultural engineering, where among his key achievements were being my graduate advisor and senior design advisor. We've been working together for a very long time. We're actually business partners now, working on engineered oyster reefs and coastal restoration. Steve's background is, or his work has been in coastal agriculture, biomass, and aquaculture, obviously. So looking forward to hearing what Steve has to say and getting the updates from Raleigh.
Fantastic. Thank you, Tyler. I'm going to see if I can share my screen here. See how this looks. Okay. Can y'all see that?
Got it.
Looks good. Thank you.
All right. So I'm going to, and you even have a little picture of me. That was my second best. Sorry, as good as it gets. So I'm going to kind of intersect, and I really enjoyed just kind of listening in on the background of what y'all are working on. A lot of interesting coastal challenges and opportunities, and bringing aquaculture, so the growing of various organisms, and I put a bunch of them up there just to give you the sense that it's not just fish. It is all kinds of different species, plants, animals, bacteria. But this is what we do. What are the intersections where we can bring some value to that coastal intersection? And then what are the ways that we can be both productive So put some value with that, but also sustainable. And you guys are obviously deeply into this conversation, so I'm just going to launch right in. And feel free to stop me or ask a question if there's need. And then give a talk, and then we can ask some more questions after. So I figured this would go together. So you can meet my family. We are part of the projected world population going in that higher direction. But very seriously, world population is continuing to rise, and certainly from the point of view of providing basic needs, including food, this is something to consider. And then with regard to the ocean in particular, we have challenges with fisheries. We have challenges with nearshore water quality. You could argue water quantity, or certainly quantity in the location where we would like it, and then habitat challenges. So I'm going to talk a little bit about how we can deal with some of these challenges, but also I want to put aquaculture, the raising of fish and seaweed and other things, in the context of other protein production industries. So if we look at protein production, this is only through 2010. We can see that pork and poultry are rising. Beef is actually declining. Sheep and goats are pretty small. Farmed fish has now roughly equaled beef and is rising faster than any other component of the protein industry. Now the challenge with that is it comes, I'm not going to say at the expense of, but there is a complementary aspect between aquaculture and capture fisheries. Around the late 80s, wild capture fisheries reached a limit, and it appears to be a pretty real limit, that we have overfished many of our fisheries. We are maybe right at the sustainable level for some others. There may be a few deep ocean areas that we might dare to take a few more fish, but basically I think we're not going to rise much more with the wild capture. So aquaculture has basically grown to keep up with that demand, and it is about equal with the total of all wild capture fisheries around the world. All the fish we're pulling out of all the oceans, we're now producing that much in aquaculture, in various ponds, tanks, net pens, and other such things. And the likely future will be that aquaculture will be substantially larger than wild capture fisheries. So that's kind of where things are going. Wild capture may even drop a little bit, and maybe aquaculture allows us to allow some of those overfished fisheries to come back a little bit. So that's kind of the idea, that actually aquaculture can help with conservation as well as with the food production. So some of these big challenges, and I finally got Tyler in a picture here. So there's Tyler. The bottom line here is creative use of technology. And this is Tyler in our group receiving the American Society of Civil Engineers Award here a few weeks ago. And congratulations to Tyler for getting that in and getting some well-deserved national attention for looking at really sustainable ways of working on coastal infrastructure and actually growing that coastal infrastructure. I'm going to just take a slice of that, or a piece of the intersection of that, where we're looking at how do we become more aware but also more creative in aquaculture and in engineering, getting those two sides, the conservation side and the production side, going. And then a little bit of what some of the big challenges are for us in the engineering side. And I'm going to try to give you a little awareness, but maybe not totally bore you. Unit operations, things like biofiltration, UV sterilization, pumps, oxygenation, degassing, water quality, but then also the kind of efficiency. How do we do this cost effectively, but also environmentally effectively? And I refuse to call nutrients waste. Nutrients are value. They're just value that may sometimes be in the wrong place. And so we are trying to find ways to add value, both in the food, but also in the biofuels and other biological value added areas. And so we're kind of just trying to be creative with our use of technology. And we're thinking about where can aquaculture grow? So aquaculture has been substantially freshwater, a lot of ponds, a lot of raceway systems, some recirculating aquaculture systems with big tanks. But where can it grow? And the answer is, think about our planet. Our planet is 70% water. So the biggest area on the planet is water. And we have what's called the Exclusive Economic Zone, EEZ zone, that is up to 200 miles offshore from every country. Our country happens to have the largest EEZ zone in the world, substantially because of some of the Pacific Islands. So you put a 200-mile circle around these Pacific Islands and you get many, many, many thousands of square miles of potential zone to work with. Now, there are also challenges with that. So marine aquaculture, that is to say near shore or offshore aquaculture, is highly likely to expand. And from here on out, I'm going to substantially move into addressing that, even though the current state of aquaculture is heavily freshwater. I think in the future, you're going to see estuary and offshore aquaculture. There's some of it will be onshore, especially maybe some of the young animals that might be done in recirculating aquaculture systems, hereafter called RAS systems. Some of it may be done in raceways where you flow ocean water or estuary water through tanks or raceways. Some of it will be in near shore, and there's already a fair amount of that. I've got some images there of some oysters and some net pens. And then I'm going to call it offshore, but less than 3 miles, and there's a fair amount of that that's already going on. But there is very little going on far offshore. And there is a lot of square miles between 3 miles offshore and 200 miles offshore. But there are also some huge technical challenges to doing that. And so I'm going to talk just a little bit about what some of those challenges are. Definitely the pure physical challenges. Offshore waves are frankly much larger than most of what we ever get onshore. I called a colleague the other day in New Hampshire and asked him a little bit about some of their offshore measurements and work. And he talked about 11-meter waves. And he didn't even make a big deal out of it. He just simply said, yep, we had some 11-meter waves the other day. 11 meters would put the building I am in, and I'm on the second floor, completely underwater. These are huge waves, and they're very common if you get offshore. And so the pure physical issues of how do you build structures, probably not structures that fully withstand the waves, but rather structures that flex with the waves or in some other way reduce the impact of those waves. Then you've got, and I threw in their distance as well. 200 miles offshore is a huge distance. So that simply implies various things, like there's probably going to be less humans out there and more automation. Biological challenges, really there are various geneticists working on ocean and estuary fish already, but aquaculture is pretty young, and so there are more biological challenges to come. But then I have these other two things that are really not engineering, but they're really important, and I wanted to admit that. And I'm really glad to hear some of you guys are actually into the marketing side and the perception side. But aquaculture is, I think, a great way to reduce our impact and to feed the world. But it has received some less than perfect perceptions in the last few years. Maybe rightfully so, but I am here to say we're going to try to do this job very responsibly. And then I think marketing. Fish are healthy. They're ethical. They can be grown fairly locally. Fish, of course, they're pretty tasty. So this should be something that's not too hard in terms of marketing. And both U.S. and world consumption of fish is in fact rising. So I think to some extent that part is happening in a good way. But some of these are going to need some responses from the engineering and technological point of view. Especially, I think we're going to see a lot of automation. I've been working on autonomous vehicles, little robotic vehicles that talk to each other and collaborate with each other in various tasks. but also robustness. When you start talking about large waves, salt water, long distances, systems have to be very robust. There's going to be certainly the biological and environmental aspects of things. How do we reduce our impact while still maximizing the growth of whatever the desired animal is? And then there's the economics and the social side that I've mentioned. So just to kind of zoom in on the physical challenges a little bit, 200 miles at 20 miles an hour is a 10-hour one-way trip. So, and again, that wave energy, I talked about 11-meter waves. There are waves bigger than that. The point is that whatever we put out there has to be significantly robust. And then I also wanted to mention there's some large animals out there. You know, how many tons is a large whale? You got significant predators out there. So whatever you put out there has to be able to not only survive, but really be robust to these sorts of situations. And some of that, I think, is going to be various kinds of local robots. Some of these are already under development. Our group has done a little bit, but there are a number of other groups around the country and around the world working on automated feeders, automated net cleaners, automated travel of boats, barges. This little picture in the lower right is some of our students looking at an autonomous vehicle just in a tank in the lab. But we put these out into open water systems, and they operate actually fairly well. They're solar powered. They can navigate. They have a GPS and a radio on them, and they'll talk to each other or back to a base station. But there's going to be a lot more of this development going on. And communications, including maybe some underwater communication, will be important. So this may be what future large emplacements look like. Nothing but a buoy on the surface, and then everything else below where much of that wave energy occurs. So we may end up submerging much of our systems and then really just communicating and monitoring from the surface, as opposed to trying to actually fight those surface waves. Aquaculture, unlike oil, so we're actually working through the specifications for future onshore or offshore aquaculture, and they are at this point somewhat based on offshore best practices for oil, which is pretty robust, but there's a lot more money in oil. There's actually, pound for pound, a little bit less money, and so these are going to have to be pretty lean systems. On the other hand, you're not going to spill 1 million gallons of oil, although you might have a few fish that get out. If you work with native species, well, you'll be really sad if you lose your fish, but you won't do immense damage to the environment. And so maybe they can be leaner systems, and then robust design, even though they are leaner. And so that's kind of where we're going with some of the answers to the physical challenges. Some of these, I didn't write it down here, but I put cameras and anti-predator bots. I think we're going to eventually have aquacultural pirates. Don't tell anybody I said that, but I think that there will actually be enough value out there. You have thousands or millions of large, high-value fish. That's going to be a temptation for somebody. Again, at 200 miles offshore, you're probably not going to hire a rent-a-cop. You're going to have some kind of a security bot that's out there. Where exactly that goes, I don't know. I hope it doesn't go to bad places, but I do think there will be some monitoring and some cameras. And then we're going to have, and we already have in other aquaculture operations, disease challenges. And I think we're going to have cleaners and bots to deal with some of those disease issues as well. And one of the big examples will be sea lice in salmon, both for the aquacultured salmon, but also for the natural animals that may come nearby. We're going to need to reduce our impact. And that means we're going to have automated devices that reduce some of those either disease or parasitic issues. Some of the biological challenges come back to really sort of the genetics of domesticated species. So this is striped bass, and then domesticated hybrid striped bass, and now we are working on developing a new domesticated purebred striped bass that is basically a natural native species off the East Coast. They are becoming more robust, but we're literally only at generation 6. And I want to put that in perspective. So we can grow these out to an adult in 2 to 3 years, and then we breed them, and we get a second generation, and we do that several times. And over 20 years, we're up to generation 6 or maybe generation 7, depending on how you count. How does this compare to other species? So by 2000 BC, chickens, pigs, camels, bees, buffalo, duck, donkey, guinea pigs, cats, dogs, cows, sheep, and goats, at least, were already domesticated. Whereas fish, koi were domesticated in the 11th century of Japan, but really that was not for food. That was primarily for the enjoyment of the nobility, the emperor. Carp in the 1200s to 1500s were developed in Asia as a cultured food species and somewhat in Europe. The next species after that was rainbow fish in the 1920s in the Pacific. And then since really the 1960s, and maybe more accurately since the 1980s, there have been a number of other species. But these are very young species. So there's a bit of a genetic bottleneck where we are working with our genetic and biological counterparts to develop robust, fast-growing, healthy species that can be cultured offshore. I would say maybe catfish is a fairly robust onshore species. Atlantic salmon maybe is the only sort of robust, reasonably well-developed offshore species. Our work on the striped bass, we've got work going on with oysters. There are a number of other species that are in very preliminary work, but there is a lot of biological work to be done to develop aquaculture to where it needs to be in another maybe 20 or 30 years. We are breeding for all kinds of great things, for resistance to diseases, for efficient growth. We are trying to some extent, leapfrog, but we don't want to do too much of the frankenfish. We want to stay as close as we can to the native, local, yes, maybe a somewhat improved, fast-growing species, but we really want to work with the native local species. In the lower left, you can see me with a sturgeon. So we are actually doing some work with them. Lower right are some of my guys at the Marine Aquaculture Research Center. They're working with striped bass. You can see some of the eggs at the Pamlico Aquaculture Field Station, upper right. And then a little more of that on the upper left, but just give you a sense that we are working on these challenges, but there are both, I think, ethical, but also perception challenges. Clearly, we're going to try to grow good fish that are healthy, but we also want to learn how to efficiently and effectively grow through the entire life cycle, from the eggs to the larval, to the grow out, to the reproduction, and then back to the eggs. And we want that production to be really sustainable. Ideally, again, that comes back to somewhat local production. So fish that would be adapted maybe to the Gulf. People have talked about drum and other such species in the Gulf. Here on the East Coast, things like striped bass might become substantial. I think shellfish are going to be a big deal. Clams, oysters. They are already great, but I could imagine, again, aquaculture producing even more oysters than nature does, because I'm going to say, take a little better care of them. And oysters are really great because they filter the water. They actually improve water quality. I'm sure Tyler's shared that with you maybe in some previous talks, but I think we need to focus on some of these species that really can enhance water quality, enhance the environment. So we're really focusing on that in a substantial way. And then we're working on some of the technologies to reduce some of the waste disease issues. Perception's another issue. I am not a big perception guy, but I recognize that we need to look the part. Aquaculture can help with wild fish. So actually, I put the alligator up there because there is a commercial, about $30 million per year, alligator industry in the state of Louisiana. And I know a number of you are sitting in Louisiana. That industry stems from some agreements between the aquaculture and culture people and the regulatory and endangered species folks. 30 or 40 years ago, people started working on this. They figured out how to capture some of those wild eggs, hatch them out, grow them out to a 4-foot length where almost nothing will eat a 4-foot alligator, and then release some of those animals back to the wild. They had very good success with that. They came up with a magic formula that was, for every 100 eggs harvested from the wild, you must release 16 4-foot animals back into the wild. And as many of you in South Louisiana are aware, the alligators are back. In fact, maybe even to the extent of being a bit of a nuisance. But that's a nice problem to have. They're no longer a threatened or endangered species, certainly not in South Louisiana. They are actually, to the extent that there's been documentation of them reducing some of the herbivores, the nutria, and helping the marsh to regrow in some areas. So there's some cool ways that aquaculture and conservation can work together. And by the way, despite putting the 16 animals back, the other 84 animals contribute to an industry that's now worth $30 million a year in Louisiana. So we've put value into that industry while doing conservation and really making both of them sustainable. So I'm looking for that possibility with other species. Sturgeon, some of the native sturgeon species, especially on the East Coast, the Atlantic sturgeon and the snub-nosed sturgeon, short-nosed sturgeon are two of the species that we are interested in and starting to do some work with. You can see me with a sturgeon, a young sturgeon there on the left-hand side. But how can we find ways to collaborate between conservation and production, make money doing it, but also help restore and enhance the world? And then another big thing is engineers can help us to monitor water quality, populations, while we are at the same time feeding the world. And I think ethically we not only can help feed the world, we really must. I think it is an ethical imperative that we provide for the people that are here and the people that are coming. We simply can't, I think, ethically say we're just going to let people starve. That is unacceptable. But I think we have to find a way to say we are going to feed people, but we're going to feed them ethically and sustainably. And so we are looking at everything from the fish themselves to also various things like post-harvest. How do we do value added? How do we do enhanced health benefits, certain omega-3 fatty acids and things like that? How do we enhance the sort of ethical or the local aspect of fish in aquaculture? So a few of the things that we're working on are some of these key current research areas in our work. By the way, these are some of our students, upper right. You're going to see them coming and going. We have a diverse array. They're every flavor, shape, size, and age. And I think it's great. We've got the whole world working on various aspects of aquaculture. So it's pretty exciting to be working in this area. But we got work to keep doing. I have a series of words here. I'm just going to try to explain them. Lower trophic levels. Most of our favorite foods, our favorite aquatic foods, are pretty high up the trophic level, which is to say they're not the algae and they're not the little fish. They're the big fish. They're the carnivorous fish. Most of us like the mahi-mahi, the tuna, the big carnivorous fish. What we're trying to do is to still provide people with the fish that they like, but to do it with foods at a lower trophic level, substituting more plant food into the diet. And we can do this in aquaculture. We also can, by getting better conversion of those nutrients, we can reduce waste. We still have some waste management issues, and so we have students working on biofiltration, enhanced biofiltration, to improve how we remove those nutrients. But we're also looking at integrated multi-trophic aquaculture, where we take some of those waste, grow algae, and then feed that to things like oysters and get another value out of that. We're working on disease management. As we mentioned before, we're also thinking about how to choose wisely what is locally advantageous Gulf Coast area, what's going to be locally advantageous in the central East Coast, what will be advantageous further north. It's going to be different species in different locations, and we need to really work on that and think about stewardship as we do that. And again, Us engineers tend to shy away from the social issues, but I think we need to at least engage on some of these social issues and think about how can we do better on that. So here's a little bit of some of the things we're doing in North Carolina. I got a picture of sturgeon there just to remind us of that. Again, working on algae, also macroalgae or seaweed. And we've got a couple of projects going right now on macroalgae. Pretty interesting stuff. Some people will eat that, and in Asia, that's a pretty common thing. But there are also a lot of value-added nutrients in macroalgae. And in addition, they also are a sort of filter system or filtration system where you remove nutrients but get a value out of that. Again, oysters, I would consider them to be pretty low on the trophic level. They filter out algae, microalgae, and other things. And some of us certainly enjoy having some oysters from time to time. Tyler, next time I'm down there, we're going to get some. And then we do certainly work on some of these higher trophic level, the salmonids, trout, bass, sturgeon, but we're going to try to even do those in a more sustainable way. And again, you can kind of see some of our students and even some of our next generation. There's my daughter in the lower right. That was a few years ago, but she's ripping into a crab there. But I think, how do we do things more efficiently and more sustainably? So I'm going to give you maybe a back up a little bit and talk a little more about the aquaculture industry. Again, worldwide, by now, about 50% of all the seafood is now aquaculture seafood. Unfortunately, the U.S. is a massive net importer. We produce between 1 to 2 billion in aquaculture production. We import something like 19 billion in seafood in general. And so we need to really work on that. So sustainability, but then also perception. We got a lot of room for growth. And so we're thinking about how do we expand in various locations. And specifically, I'm very interested in the Gulf Coast and the East Coast. Again, now we're sort of getting into some of the details of working with some of our particular people and some of our particular products. I am going to explain this fish FCR in the second line, feed conversion ratio. How many pounds of feed do you have to feed to a cow to get 1 pound of beef? And the answer is something like 20. How many pounds of feed do you have to feed to a pig? It's less than that. Chickens, less than that. Fish, even less than that. I recently heard a number that was 0.69. Now that sounds a little bit like you're cheating the laws of thermodynamics, but they reminded us that's 0.69 dry feed weight to a 1 pound wet weight for the fish. But there are ways, if you can grow roughly a pound of fish for every pound of feed and take the waste and grow some additional plant products, you actually can have a feed conversion ratio that is better than 1. So that's actually sort of exciting from a technical point of view. At the end of the day, that is also going to contribute to farmers' bottom line. And it also ultimately contributes to enhanced stewardship. Mentioned the recirculating aquaculture, where we recirculate water. We therefore don't overuse the water. I mentioned integrated multi-trophic aquaculture, where we're using different trophic levels. Algae feed the oysters or other small fish. Those may feed larger fish. We've actually addressed some wetland issues, and I consider that to be part of aquaculture, is growing things in water, in wetland areas. How do we encourage that? Some of the pre-discussion that I heard was talking about how perhaps some of the proposed changes in South Louisiana might enhance ecosystem services. We certainly are very, very interested in enhancing ecosystem services, adding value wherever we can. Some of our collaborations recently have been with big data people. So Natalie Nelson is one of our PhD colleagues here. She is a big data person looking at how do we enhance through things like aquaculture, but also other coastal activities, local impact, and then also some of the concerns for which areas are most resilient in the face of various impacts like coastal storms. And then what can we do to enhance that resilience. And you guys, I think, are very, very interested in that in your various local areas as well. So those are definitely of interest. Here's just a quick preview of the MARC facility. There's 2 buildings there, one of them with these smaller tank systems and then one of them with larger tank systems. We are doing a little bit of solar and wind energy. We're also doing a bunch of water quality treatment and growing out. A lot of our work there has been on oysters, striped bass, and then also a little bit of work on algae and a little bit of work on bait fish, but we are interested. And then we're right across the street from one of the largest sturgeon facilities in North Carolina, maybe one of the largest in North America. And that also is a recirculating system. Those sturgeon are grown up to quite a large size. Some of those animals get to be 50 to 100 pounds. It's a multi-million-dollar operation. It's a multi-acre operation, but it is largely recirculating. That water comes up out of the wells, it gets treated, gets circulated through the systems, and then comes back in, gets cleaned up through various biofiltration techniques and gets recirculated back into the system. So we are being very efficient with our water use. And so I'm just going to wrap it up at that point. We're really trying to get super efficient at growing fish. We got a lot of work to do, everything from trying to get lower on that trophic level to be really efficient with our resources, but also some really cool, slightly scary, but kind of cool automation, autonomous vehicles, robustness, and then really kind of some of the social and international work. We've got a couple projects that are just cranking up in Peru right now. I have done work in the past in Central America, in South Africa, and other places. And I do think that our work needs to impact locally very well, but also where we can transfer that and improve things around the world, we need to do that. So in the end, we're engineering for production, but we're also engineering for sustainability. And if we do those two, we will get growth. So I'm going to stop at that point and maybe take any questions you all might have.
Steve, this is Charles. Excellent presentation. Thank you so much. My first question is, as a Louisianian, what exactly do you do with a sturgeon?
Can you repeat the end of that?
Sure, I'm kind of being silly, but in what sense? What exactly do you do with a sturgeon?
Oh yeah. We do test the product every once in a while. Yes, indeed. We actually, at the MARC facility, we grow so many animals that we actually do sell those commercially. We are not allowed to formally compete with other businesses because we're a state entity, but we do sell those to relevant locations. We've actually had some interaction with prisons and schools with regard to that. And definitely we test the product every once in a while to make sure it's good, and I assure you it's good. So we'll keep.
Charles?
Go ahead, please.
This is Val. Thank you, Steve. It was a very interesting presentation. I have 2 questions. One is, do you guys are you a Sea Grant university? I just didn't look. Or do you work with them in terms of the commercialization of this?
Absolutely, yes. So NC State is, like LSU, it's a Sea Grant university. And we have a very good working relationship. There's a center at the coast called CMAS, Center for Marine Sciences and Technology. Our little facility is about 20 miles from them. We overlap with there's a number of their people that are working in often the biology and the coastal areas. But for example, oyster technology is something that we overlap in. Some of the other water quality technology aspects, we have some overlap. So yeah, that's a very good working relationship. Sea Grant is a great resource. Yeah.
And so my second point is I guess the disappointment that fields do not work across each other and cross-pollinate well enough. And we were talking in wait for the meeting about money being spent to come down and talk about what could happen in coastal Louisiana, particularly in Terrebonne and Lafourche parishes. And, this seems to be such a obvious choice for a group that came down and assessed what could happen to make the region more adaptable for the future. And it didn't appear in their research. They spent a lot of time and effort on it. And, it just, this seems so obvious to me for South Louisiana. And I wonder why the disciplines aren't crossing more to make this more obvious, and to pull money and put it into this type of activity.
Yeah, well, and I'm sorry to hear that. Louisiana actually is the #1 aquaculture state, but the majority of that is freshwater. A lot of catfish, #1 in crawfish. But there is a substantial coastal aquaculture industry, and there could be a large coastal aquaculture industry. And I agree that that is something that Louisiana, frankly, is already pretty good at. It's a way of, I think, valuing the coastal areas. And I think that's one of the biggest challenges is how do you get people, especially people maybe in the cities that they're so far away. Well, yeah, maybe the coast is receding a bit, but it doesn't really bother me. How do you get people to really come to grips with that and acknowledge that? And then how do you sustainably expand the industry? And I think, again, I mentioned the marine. My own work had been nominally marine until a few years ago, and it's become apparent to me that's where the expansion is going to be. I do think the agencies and the groupings are starting to cross-pollinate a little better, and I'm certainly very interested. So if you want to connect me with anybody, I am happy to talk to them. But yeah, I mean, I think that we need to be thinking that way, whether our quote-unquote experts are thinking that way or not. We need to find ways to connect and to enhance value.
Yeah, and I'll stop because I don't want to over talk this, but it could be a project of the Rotary to have in our suggestion box one of the prime ways for restoration to come within some of our zones is through aquaculture. I'll stop with that. We'll pick up more, and I'll look at your summary again, I'm sure. Thank you.
Great. Thank you.
Let me just follow up again with what Val was just mentioning. I was sitting here while I was watching your presentation. I'm not sure I was thinking the same thing as Val was. We have a humongous, obviously, coastal area and I know that the freshwater aquaculture is very big in the state. I was just kind of wondering the same thing. As far as offshore, we have a relatively short way to go before you hit the continental shelf off of Louisiana, where you can get to those deep water fish. Unfortunately, I guess we have the dead zone coming off the Mississippi, which could be a hindrance to what's growing out there. But things seem to be growing where it's not the dead zone. I was really impressed by that. It just again, from a perspective of we're importing $19 billion worth of aquaculture grown fish or fishery products versus producing 1.9 billion. There's definitely a grow an American, buy an American effort being made right now. So I might be able to attract some investment money to look at that a little bit more heavily. Again, I love the presentation. It was great.
Yeah, those are great observations. Absolutely. I also think, each of us has to play the cards we have as well as we can. Louisiana has the substantial offshore oil industry, and I think there's room there to, again, sort of connect with that. And some people are working on that. Again, I've been in touch with some of the people that are working up some of the standards for offshore Gulf aquaculture. And that's still in process, but that's definitely something that's in play. And in case of Louisiana and some of those areas, with the oil industry already there, the potential to sort of piggyback on that and put some emplacements that are near or not so far from some of those oil emplacements would give you a base to work from that would give you that offshore water, but also be able to access it fairly easily. And here in North Carolina, we're actually at the juncture between the southern waters and the northern waters. There's two flows that come out. So we're actually at a point where we have certain advantages, if you want to call it that, where we can work with both the cool water species and the warm water species. And I think we need to play those cards. And so everybody sort of has different cards to play. And I think it's important that we work with the strengths we have. I also was thinking about your comments on the dead zone. So the hypoxic zone is a reality, but that also is something that we do have some level of control over through our policies and practices. And so I think if we can find ways to work with that in such a way that we maybe reduce the dead zone and enhance aquaculture in some form or fashion, that maybe there's a way to do that such that you actually get two for the price of one, or get a benefit instead of a liability. So maybe just those thoughts for now, but I much appreciate your comments and encouragement.
Steve, this is Stan at Florida Earth. Can you hear me?
I can hear you.
Yeah, we have a partnership with a university in the Netherlands, Wageningen University, and they have a aquaculture department there that is working on what they call layered growth, where they're doing a multiplicity of species in the same operation to lessen the impact of kind of the crowded conditions. So, for example, they're doing flounder and mussels and edible seaweed in the same operation, and what they're finding is that it's returning water cleaner than what they take in. So, if you would like contact information on the scientists there that are doing that, I can get it to you.
That'd be great. Thank you, Stan. Yeah. So that's a little bit like the integrated multi-trophic work, but definitely Wageningen is really one of the finest European agriculture and aquaculture institutions, and would be happy to talk to them. I think you can contact me directly, shall5@ncsu.edu, or you can just get the information, Tyler, and we'll connect up. But much appreciate that.
Great questions, and love the dialogue. I mean, this is what Rotarians do, is that, we cause things to happen. And kind of queuing off of Val's comments earlier, I think our club isn't just a perfect forum, a perfect format for connecting the dots that may not connect completely yet. And Steve, thank you so much for your presentation. Clearly, you sparked a lot of interest in the topic. From the feedback we've gotten today. Very much appreciate it. Just a kind of a closing comment, having lived on the bayou, one of the encouraging things I see from your presentation is maybe helping us to shift from a consumption mentality into a stewardship mentality. Because I know even the people that historically have lived off the water still have very much consumption mentality. And what I mean by that, not protecting it, trashing it, dumping motor oil into it, just cutting canals through the marsh, things like that. Again, which historically didn't matter because they could absorb all it could take. Well, it's no longer the case, and perhaps if they see an economic value to it, the stewardship might rise up a little bit, I hope.
Wonderful. Thank you, Charles. Thank you, everybody. It's been a pleasure.
Good. All right. Well, everybody, thanks for joining us. We'll do this again in 2 weeks, and we'll see you then. Thanks.
Thank you. Bye.
Thank you.